have to structure kind of the whole work and the whole project based around that. That's kind of part of the reason why we do so much commercial off-the-shelf stuff, because it means we have to do less work, and that's really good, because we just don't have the resources or the time to do that, kind of.
Sorry to scare everybody. This is Tyler. I wanted him to join us tonight. He's also available for Q&A. He's the engineer, so if you want to know how we did something, you can ask him. But keep asking rLoop questions too. Hi, Tyler. Yeah, you probably can't hear him. I don't know. Sorry, Tyler. He gets it.
Should throw that thing.
Who's next?
Throw it around.
I guess. Nice throw.
Okay, so I heard about this Hyperloop project a long time ago, and I've been always curious about what kind of material that like the tube is made of.
Steel 838.
And is this strong enough? And you know, since it's vacuum, right? Inside is vacuum, and then how you guys deal with the wind drag and the seismic force, you know, all kinds of stuff, because it's upright.
Yeah, so I'm going to take that on vacuum. So basically, from the theoretical point of view and terminology point of view, it's not even vacuum. We're going to have 0.125 psi, so it's not even low vacuum, it's actually just low pressure. And in terms
1,000th of the pressure you have in the atmosphere-ish.
Yeah, but if you ask a vacuum engineer, what's that? He would, laugh in your face, because it's nothing basically for these guys.
Louder, Amir, louder. Say that again, but in the mic.
So I am Amir, numerical simulation lead, so I've done a lot of analysis work on this, what you're asking. So this is not really a vacuum. Vacuum is like 10 to power minus 7, 8 millitorrs. And this is just a low pressure environment. It's not really vacuum. It's 860 Pascal or 0.125 PSI. So whenever you calculate that, like in an aircraft, you have a fuselage, you have an internal pressure, that's 1 atm, and outside, that's a different pressure. So how you calculate the pressure load is you get the pressure differential from the outer atmosphere to the inner atmosphere. So if you take that, and we have done that, and we have about 2.97 as a margin of safety on that material, what you're talking about. But I think your question was regarding that in vacuum, molecules disintegrate, outgassing happens, so this is not a vacuum, so that's not going to happen anyway. So in my point of view, and theoretically, and more logical manner, it's very feasible, and it will happen. So
thank you.
Is being that you're dealing with so many people who are coming in and out of the project, is there some type of versioning control you have to do to kind of keep the latest level of progress between everybody? And
So
how do you approach that?
So your question was about the quality of the whole system?
About the versioning. About the
Versioning.
versioning, yeah, how do we...
It's we have all those people collaborating together, right? But behind that, there is also some people kind of making sure everything is running right. So we have those team leads and all the people over making sure those things are coming along the right way. So it's a lot of meeting, a lot of discussion to see all those version progress, and just see. We have kind of key decision point meetings. Say, okay, are we going this or are we going that? Are we going with that version? Okay, if we're moving with that, what are the different issues and so forth? So actually having all the eyes, it's always like someone is checking over your shoulder all the time. You have like 5 layers of over the shoulder looking that you have, that it's really getting checked all the time in that way. Did that answer your question?
Yeah.
Well, we also use, more specifically, we use Jira for sort of task tracking like you do in most software projects. And we also have, we've done a number of like design documents where we sort of, that was mainly for SpaceX. They want you to send in a couple of like 200-page design documents where they can read all about it. So and that's been kind of some of the key decision points where we make those big documents. That's where we sort of have to write down everything that we have at this point and sort of what the design looks like right now.
Yeah, so a very good point. I mean, is that we've got this amazing systems engineer and he's doing an amazing job of keeping us like putting stuff into documentation and actually trying to, save that knowledge somewhere.
Yeah, we basically have a team whose job it is to keep track of stuff.
Well, that's the system engineering team. So that's what they do. It's really to set the requirements. Say, okay, this part needs to be between those tolerances. Need to be able to do that exactly, and that's a one-stop shop for everybody when they need to design something. It's okay. If what I'm designing right now, is it answering those requirements? So that's very important. It's really the backbone of the whole thing.
Yeah, I definitely recommend systems engineers to like every startups, projects, and so on. It's amazing.
Yes.
I haven't had that before, and it makes a difference.
And it's very funny because in the beginning of rLoop, I remember when we were creating all the teams, and we had system engineering team, and some people were joining, and they were a bit confused. Okay, what do they do exactly? And once you had some people that kind of knew what the job was and the requirements, like, oh boy, okay, they are the one you go to when you need to know exactly, if you do a small project, it's time, okay, we need to make a table that is that long. Okay, that seems pretty easy. And then you need to make a whole building with all the tables, all the stuff in there. You need to have a one-stop shop where you have the dimensions for all those things so they can fit all together at the end. That's the job of the system engineering team, making sure that all the parts come together, that you have the electrical box that you're making. You have the electrical engineer just thinking about his world. Okay, I'm making my control, my nodes and stuff. If the mechanical engineer thinking about his world, you need to make sure they talk to each other to have the electrical box sitting inside a part. That's the system engineering work. So that's having that really made a difference with the success of the design.
Very, very cool. And then the other question was, where do you see AR fitting into this? What is the vision for AR? Is it like as the pod's moving, somebody's monitoring, or how do you guys envision that?
So
I would say I think the main application would be some kind of virtual reality windows for it, or maybe sort of onboard entertainment. Maybe you want to give the passengers sort of a Oculus Rift, or some kind of headset, and they could watch movies or Netflix or anything like that while they're
But in the that's for the final end goal, and I agree with that. For the Hyperloop project, it's what we've been working with those guys. Is really I'm a test engineer. I've been doing a lot of stuff and looking at having a screen with all the information in there and looking at all the stuff at the same time. You want to look over your system at the same time. It's good to be able to manage to put all that information at the same time on the thing. So for the Hyperloop competition, I'm really looking forward having a headset during the competition and being able to look at the pod and looking at those videos at the same time. Okay, on the top right, I see my speed, and then I see a blinking alarm here. This might mean something. So it's very important to be able to prioritize information. I'm really looking forward to that. And I think the AR and VR will really be a huge help in all that technology. I think what you showed with ESA is a great application of the stuff for the future. We've been using screens for a long time for that kind of stuff, but there are smarter ways to channel the information. So there is the entertainment world, which is great. More on the engineering world, there is really endless possibilities of stuff you can do nowadays. It's really an emerging market, and I think in the future we'll be blown away all the stuff we can do so efficiently. And looking forward that for the Hyperloop.
Yeah. Just one more quick point. I definitely see also one more application for that. That will be maintenance. So if you have any huge industrial installation, and Hyperloop definitely will be one, safety is always a concern. So if you send people, for instance, like down the track, down the tube, they have to go there. There might be no light, like can be still, I don't know, a temperature can be high. So you don't want them to focus on checking up, on Google Maps where they are. So it will be way better to, display that information directly to them so that they can focus at actually getting the job done.
Another example in the thing I just thought about is really like a checklist. When you do tests, you have to have checklists. You have to have procedures and look at those things. Okay, power is on a 60 volt. Okay, it's done. And here, having augmented reality for that is great because you have the checklist on the corner of your eyes. You can look at it, check it with one way, and just look at the thing at the same time. So, that disconnection between what you're looking and then looking back at the sheet, checking it and going back, okay, where was I? Okay, where was that thing? Wait, was that thing there before? That kind of stuff. It's great to keep your eyes on the important parts. So that's another great thing you can do with AR. All right.
So I have two questions. One of them is, have you thought of any way to wirelessly charge the loop while it's running? Or how do you deal with the charging situation, because you need to keep it running on a schedule?
So it's extremely. We're talking about a lot of power in the system. It's like 30 kilowatt batteries, 30 kilowatt hours batteries, and just the charging system. We're just having a headache right now in terms of figuring out the right charger, because we cannot use 3-phase and it needs to be single phase, and we are high current, low voltage batteries, so we need to find the right charger for that. Remote charging is great for smaller things, not really applicable for that thing like here that consume a lot of power, unfortunately. Maybe in the future, but as of right now, it's not really feasible.
Okay, my second question is, you're in a very low pressure, low air environment, and you have a lot of electric parts. How do you deal with heat dissipation?
That's an extremely good question. It's been a hot topic since the beginning. I'm not a comedian either. So that's why we have a pressure vessel that keeps a lot of the wires and the battery packs inside there. So the battery pack themselves, for heat dissipation, we're using phase change material, so just material that will become solid to liquid, and that just keeping the heat in there. That's one way to do it. And the rest, we just have enough air inside the system. No, our hover engines right now, we have some ways to cool them, but we're thinking right now to just let them get hot. And because the whole run for the competition is going to be less than 30 seconds, it's really fast. So they should be fine. Those engines should be fine. For the final system, the big advantage you have here for the final system is in ours, as you saw, we don't have a compressor because the kind of speed and scale we have doesn't really make sense. For the high speed, the final system, you'll have that compressor sucking out that extra air. That air can be used for heat dissipation. And that will be happy to use it. So for us, it's a very hard task right now, the heat dissipation.
Plus, additionally, also for the final application, you can use CO2 cooling, and there are basically many ways how to approach that problem, but it's not our problem at the moment.
One thing also about maybe the wireless charging, once the pod is actually at speed, it requires sort of very little energy to actually stay at that speed, since you don't have any friction from the ground and you have very little friction from the air. So, and the power you need to accelerate the pod, actually, you can draw that from a power plant or something like that, because you have these linear accelerators. You don't actually have the engine on board the pod. So the big power requirement, actually, you can draw from grid power, which is really handy.
Between now and your test or your demo in Hawthorne, what are like the biggest challenges that you still have to kind of overcome?
Build a pod.
It turns out manufacturing is really hard.
Well, I mean, it's a theory to practice moment, you know, and I've done that in the past. Like a lot of other engineers that had that experience in the past. You think you have everything nailed on paper, or it's great, it's gonna be beautiful. You have that perfect intersection and all. And then you actually come with the thing like, okay, it might be more complicated than expected. This kind of stuff we're doing, but so far so good. We have no real major issues. It's just a matter of keeping, it's really a management issue in the thing. Just making sure all the tasks are going down. Okay, we're respecting the schedule, all that stuff. We haven't run into big problems so far. All of them have been tackled.
I can say from a controls perspective, basically, you can be thinking like for a year how to do that control system, but if you don't have the real parts, if you don't have the hardware, if you don't have the sensors like connected together, you can never anticipate every single problem that will come, on the way. So basically what you want to do, you basically want to have the hardware as soon as possible, and just a connection can take like 80% of your work, because you have different protocols, they have to communicate, between each other. You guys might know that like trying to connect, your phone over Bluetooth to a car. Like in some cars it might be easy, in some cars you might never get that. So it's very similar if you have a more advanced system with just more protocols.
Yes, sir.
Hi, are you guys leveraging any 3D printing to source a few things, or I know SpaceX uses metal 3D printers to build some of their engine parts, and are they maybe allowing you to use that, or?
Oh, we wish.
we don't have any parts that have some fancy shapes that will have to be 3D printed in metal. But if we have anything that can be 3D printed just for prototyping, for instance, we use it. Well, that's way easier, that's quicker. But like from the theoretical point of view, there's no part that will have some better parameters if it was 3D printed.
What is your
Basically, that's a
feature about the Meta headset?
I'm sorry, what?
What is your favorite feature about
Oh.
the Meta headset?
I think it's hand tracking, because as you know, humans, we love to use our hands, and now that you have everything in your field of view, it's like you get to do so much with your hands, and I think that's really cool. Tyler, what's your favorite part of the 3D headset, the Meta? If you can, I'll say it back. So. Maybe this will work. Oh, I think he's cutting out. Well,
Technology.
I'll speak for Tyler. He also likes the hands. No, he might like voice. He might like voice control, I think.
One thing I haven't heard addressed is to what degree have you been using VR and AR the way NASA has been doing since the 80s to design the Ares and so forth? What degree are you using AR and VR in the design of the rLoop, and to what degree do you expect that it will be useful in the actual engineering and execution of this project? Thank you.
So far, we have not been using it actively. We are looking forward working with those guys to make that a reality. In the future, I think we covered it a bit already: maintenance, active control, checklist, and user entertainment on board. And that's just on top of my head, but I think all you guys in the room can probably think of a bunch of other applications.
I think there's another application. I think we talked a little bit about it. It's designing and simulating things. So let's say like you have the pod moving, and you can actually see it, to scale, and you can run like, 500 simulations at one time, and you have one of those simulations in front of you. Well, you can actually reach out, pick it up when you have like a faulty simulation, and then you can examine the CAD model, it breaks apart, and then you can, grab this, and then you have MATLAB running, you're running, some experiment on it, you can actually tweak the parameters of the magnet or something to optimize your design, and then send that off to your manufacturer. I think that's another one.
I'm waiting for that personally.
We're working on it. Very
Trying to interface MATLAB with LabVIEW took me months.
It's doable.
Of course, but it takes a lot.
This is on the developer side. Can you tell us what toolkits you're using to develop the AR application? And
I can, and
what's
hopefully.
the easiest ways to get started?
Sorry for cutting you off.
What's the easiest way to get started?
Yeah. Okay. So Tyler, are you? I'm hoping the video is good.
I can hear you. Can you repeat the question?
Yeah. So the question is, what tools are we using for development, and what's the easiest way to get started? And can I see a mic? I don't know if this will work or not. All right, go ahead and talk.
The question that I heard was what tools are we using for development, and the rest of it got cut off. But what we're using is Unity 3D.
So we're using Unity 3D. Okay.
Does it have like an AR specific tool?
Does it have a AR specific toolkit?
Whichever headset we're using, they have an SDK.
So I'll add onto that some. We're also using a few different APIs, like we've been messing around with API.ai. And the hard thing for us to get started is we haven't had an SDK to work with. All these manufacturers across all the headsets, they're just now like shipping them, so that we don't have their SDK. So we have to get inventive. So right now for us, it's just Unity 3D. Tyler's actually been writing some artificial intelligence that watches the user's behavior and then will move a window. But it's not like it's fully functioning yet. But yeah, so we get creative with APIs. We use Unity 3D. I'm working in Blender and Photoshop and Illustrator, and we're just using our imaginations and hacking it together as much as we can. Yeah.
Meta has a Unity package, and you can make an app in less than 2 hours.
Yeah. Have you done that before?
I used to work at Meta.
Oh, no way. Very cool. Any other questions?
All right.
All right. Well, no, if not, thank you very much for coming out tonight, guys. This was really cool. We're going to head to a bar downstairs. It's called McKellar. Okay, I didn't want to say something.
That's a good one. You should go there, yeah.
Oh, yeah. Oh, yeah. So maybe we'll see you down there. And if not, happy hacking. We'll see you next time.
Howdy, folks. If I could please implore you to clean up your plates and bottles and cans. Thank you so much.